In this video, we will talk about vectors. The C++ standard library contains code for data structures, algorithms, and other utilities. The main data structure that we use is the vector. A vector is part of C++ code. One can also use C-style arrays, but the vector is safer to use and it's what we will mostly focus on for now. To use a vector, we need to include a vector library, and we can do that using the include command and then vector in angled brackets. The implementation for the vector uses two concepts that we have not covered yet. These are object-oriented programming and templates. These are both C++ additions to the C language, and they will be covered in more detail later in this class. But for now, we'll just introduce them briefly and just introduce the concepts we need and the syntax we need in order to discuss and use vectors. So first of all, let's talk about templates. These are used when we have a function or a data structure that makes sense with variables of different type, such as doubles, integers, and so on. A vector makes sense with all kinds of data types. So you can have a vector of doubles, a vector of integers, a vector of characters or strings, and so on. The specific data type used is put in angled brackets. For example, a vector of doubles is declared using vector and then the word double in angled brackets. So the following command declares a vector of doubles, but so far it's empty. So I can say vector, angle brackets, double, close angle brackets, and then v. That's the name of the vector. So here I have declared the vector, but I have not initialized it. So it's empty. It doesn't have any elements so far. Objects in C++ can be, in general, a class or a struct. That's short for structure. Objects are collections of data that have functions to act on that data. Here is a vector of size 5, and each element is equal to 1. So I declare that using vector double v, and then to initialize it, I use parentheses, and then first I declare the size of the vector, in this case n, which is 5, and then I can state what the elements of the vector will be. If it's going to be a vector of constants, a constant vector, then I can simply say 1. So in this case, the elements of a vector of this vector v will be 1, 1, 1, 1, 1. So 5 elements of 1. Then if I want to ask for the size of this vector, I can use the dot operator. So the dot operator is how objects call the functions that act on their data. So in this case, I'm calling the function size, and it's a function because it has these parentheses. And then if I want to apply this function on the vector v, I can do that using the command v.size. And that command will apply the function size onto the vector v and return the size of the vector, which is 5 in this case. So the function will look at the data contained in the vector, look how many elements there are in that vector, and will just return the size or the number of elements in that vector. And of course I use cout to print that to the screen and end the line to go to the next line. Now, if I want to access the elements of the vector, I can use square brackets. So the each square bracket will access an individual element. For example, v of 0 will access the first element, v of 1 will access the second element, and so on. And in this case, it's a vector of 5 elements that we just declared. So v of 4 will access the last element In general, the counting goes from 0 to n-1, where n is the size of the vector. So this is the case in C++. The counting of vectors goes from 0 up to n-1. This program will define a vector, a constant vector of size 5. Each element is 1, just as we did before. And then it uses a for loop to access each element and print it to the screen. So if we run this, it will simply show the elements of the vector one after another, 1, 1, 1, 1, 1. If I want to change the elements of a vector, this is one way to do it. In this case, again, I declare an integer n equals 5, and then I declare a vector of integers, v of n, so that will create a vector with 5 slots in it, but the slots will be empty. So for now, we have created a vector of 5 elements, but we haven't defined the elements yet. Then I can define the first element by saying, for example, v of 0 equals 1. That will make the first element equal to 1. And then I can use a for loop to initialize the rest of the elements. And inside that for loop, I have some kind of iteration or some kind of relation that I can apply in each step of that iteration. So this equation relates v of I to the previous element v I minus 1. And in this case, it will double each element. So the first element is 1, the second element will be 2, the next element would be 4, then 8, and so on. So each element is twice the previous element. And I can use a for loop that starts from I equals 1, and you have to be careful here not to exceed the range of v. So if I use I equals 1 here, this will define v1 as a function of v0. So 1 is the correct starting point. And then it will go up to I lower than v dot size. Remember, this is going to return 5, so I lower than 5. So that means it will go up to I equals 4. And so the last equality will be v of 4 equals 2 times v3. So again, we're using v4 here, which is the last element of v. So remember, v has 5 elements, so the last one is v4. So we're not going out of range. So here we created a vector of type integer, and we only specified the size initially. And then we changed each element one time. And by doing that, we defined the vector vi for all values of I, going from 0 up to 4, which is the highest value. Now we could have I lower than n here in this example instead of I lower than v dot size. That would do the same thing. So n equals 5. So and I used n here to define the vector. So if I use v dot size, it will still be equal to n. But this is using object-oriented programming, so applying the size function to v. So these two commands are equivalent. It's a little safer to use v.size just in case something happens and the variable n changes, or if the size of v changes. It's a bit safer to keep track of the size of v using this function. There are a few more ways of initializing a vector. For example, we can also use a list of elements to initialize a vector. This is a more recent addition to C++ that was added in 2011. So if you look at older textbooks, you may not find this way of defining a vector, but it should be there in more recent textbooks published after 2011. There are two equivalent ways, either with or without an equals. So these two commands both create a vector of size 3 with the given elements. So in this case, I say vector integer in these brackets, in angled brackets, and then v equals, and then curly brackets, and then the elements 6, 8, 1. Then I close the curly brackets and semicolon to end that line. So this makes it clear that the vector is a list of elements or a collection of elements 6, 8, and 1. I can do the same definition and omit the equals, and it will have the exact same effect. So in this case, W is declared and set equal to the list 6, 8, and 1. So these two ways of defining a vector are completely equivalent. Okay, so to summarize, this is a number of ways of initializing a vector. So first of all, I can create an empty vector initially with size 0 by using the command vector, angle brackets, double, and then the name of the vector. And then that's just declaring it. I haven't filled in any of its elements. Then if I want to create a vector of a certain size n, I can say vector double v and then the size of the vector in parentheses. So this command will create a vector of size n, but the vector will be empty. It will not have actual values in each element. Now, if I want to give each element the same value, I could use this command. So that would be vector double v and then the size of the vector and then the constant element that I want. So if x here is a double, then and n is an integer, then that would create a vector of size n, and each element will be equal to this double x, and all elements would be the same. It would all be equal to x. And finally, if I want to initialize a vector using a list of numbers, then I can say vector double v and then use curly brackets and just put in the list of numbers in here. So for example, this list of doubles is 6.3, 8.1, and 1.7. So that creates a vector of size 3, and each element is a double. They're not equal to each other. I'm explicitly defining each element by putting the numbers in this list. Now let's talk about growing a vector. In general, I do not recommend doing this. In general, I recommend keeping the sizes of your vectors fixed and just filling them values in as you need to. For example, when solving differential equations and you know you're going to evolve them for 100 time steps, then just create a vector of size 100 and don't change its size. Changing the size of vectors can be computationally expensive, although these commands in C++ have been optimized to make these operations faster. Still, the computer has to occupy some memory to store the values of the vector, and if you keep changing the size of the vector, it will keep having to change the number or change the location of the vector in memory, and change the way it accesses the elements and so on. So you're adding overhead, computational overhead to your program, and it's also more error prone. So if you can avoid changing the size of your vectors, you should avoid it. And just use fixed size of vectors whenever you can. Now, that said, here's the way to change the size. So instead of specifying the size initially, we can let the vector grow as needed using the function pushback. So if I want to access the current vector and the last element of the current vector, that can be done using the function back. So here's an example of how I would use that. If I create a vector of size 6, I can do that using the vector command and then int and then the name of the vector v. So that's a vector of 6 integers. And let's say I want to add one element to this list or to this vector. If I want to add one element, I can say v dot pushback 1. So what that will do is it will add the number 1 at the end of the vector v. Okay, now if I want to add more elements, I can do that using a for loop. So in this case, remember, when I declared the vector, I didn't declare its size. I just declared the name of the vector v. I didn't specify its size or its elements. So initially, the vector v is empty. Then when I say v.pushback1, that will add the element 1 into the vector. So after I run this command, the vector will be simply the list 1. It will just have the number 1 in it and nothing else. So its size will be 1, and the first element and last element will be equal to 1. Then if I want to add more elements, I can do that using this for loop. So I can say for int I equals 1 up to I lower than n, and I goes to I plus 1 or I plus plus. And then I want each element to be twice the previous one. So to do that, I can say v.pushback, and then I can put the element that I want to add inside the parentheses here. Now I want to add twice the previous element. So as mentioned here, the last element of the current vector can be accessed using .back. So if I say v.back and then parentheses, this will apply the back function onto v. So this will access the last element of v. And the last element of v, the first time I'm running the loop, will be 1. And then I multiply that by 2. So then I get the number 2 in here, and by using pushback, I'm adding the number 2 into that list or into that vector. So after I run the first iteration of this for loop, the vector v will consist of the numbers 1 and then 2. Now the next time I execute this loop, when I equals 2, when I say v.back, it will access the last element, which was 2, multiply that by 2, which is 4. So it's gonna add 4 it's going to append 4 at the end of this vector v. So then the elements of the vector will be 1, 2, 4. And again, the next time this will be double, so it will be 8. So then the vector will become 1, 2, 4, 8, and so on. So by using the v.pushback function, I can append elements at the end of the vector, and by using the v.back function, I can access the last element of the vector and do operations in it, such as multiply it by 2 and then append that at the end of the vector. Here are some other useful vector operations. Again, I don't recommend using them. I recommend writing a program in a way that you don't have to use these commands. But if you do need to use them, then here they are. So to resize a vector, you can say v.resize and then state the new size of the vector. So if I first start with a vector that is of size m, and then I can say v.resize n, and that will change the size of the vector and will simply make the size equal to n. If I want to clear a vector, clear all its values and give it 0 size, then I can use v.clear. So apply the clear function onto the vector v. And if I want to remove the last element of the vector and reduce the size of the vector by 1, then I can say v.popback, and that will essentially drop the last size of the vector. You have to be careful to not run your subscript out of range. If the vector is of size n, then you should only try to access elements with index from 0 to n minus 1. So if I try and run v of n or v of minus 1, for example, it will return an error usually, but not always. So for example, in Visual Studio debug mode, and that's a default most of us have been using so far, errors such as in the last line, in the last 3 lines below here, will cause the program to stop and an error message to appear. So in this case, I have declared a vector of size 4, and then all elements are equal to 3. But that doesn't matter. What matters is the size of the vector is 4. So I should only try to access the indices from 0 to 3, basically. So if I try v of 6 to set that equal to something, I'm going to get an error. If I try to access v of minus 1 and print it on the screen, I'm going to get an error. If I try v of 4, I'm going to get an error. All of those are out of range. So if the size is 4, I should only try to access the elements v of 0 up to v of 3. Now, Visual Studio and other similar compilers have a debug and release mode. And we have typically been using the debug mode so far. The debug mode may do more checking when the program runs. And the debug mode allows us to step through the program as it runs to see the values of variables. We will cover this soon. The release mode is what one typically uses to compile programs which run faster. but they have less error checking. So if you try Visual Studio in release mode, then the vector range errors do not lead to the program stopping. But if you use debug mode, the program will stop when these errors occur. That's all for this video. Thank you for watching.